Hello, everybody. Thank you for joining us for part 2 of our two-part series on root cause analysis. Today's presentation is root cause analysis, getting it right out of the gate with ASU instructor Dani Picciotti. She has rejoined us for this webinar. Before we begin, a few housekeeping items. Only the panelists are displayed and heard, but we do want to hear from you. Please put your questions into the Q&A panel of the site, not the chat. We will be sharing both the recording link and the slide deck for this presentation this afternoon after the session is over. A little bit about your host of today's webinar, Intellect. My name is Raquel Cloyd. I'm the Business Development Manager here at Intellect. In case you are not familiar with us, we are an out-of-the-box, no-code compliance, quality management, and environmental health and safety software solution. We work with companies across various industries to help them automate their quality and EHS processes. We help them save time preparing for audits, maintain regulatory compliance, and to do so efficiently and in a user-friendly manner. I'd like to introduce our speaker today. Dani Picciotti has over 25 years experience in quality and mission assurance organization across many industries, including Fortune 500 companies. She is process focused. She emphasizes continuous improvement and value-added activities. She's an ASQ course instructor. She's recently developed a curriculum for ASQ on root cause analysis, and we will link to that course at the end of the presentation. Dani is also president of QMS Alliance. And at this point, Dani, I'll hand it over to you and you can share with the audience a bit about your company.
So thank you so much, Raquel. And thank you everyone for taking time out of your day to explore this root cause analysis process. So a little bit about QMS Alliance. It is a quality management system consulting firm. We're based in San Diego, but work with customers across the country and even internationally. Our primary focus is in quality management systems, whether it's developing policies and procedures, performing internal audits, or even helping with your supplier management. We do like to be flexible with our clients to help them on their journey, whether it's exploring new quality system certifications like ISO 9001 or AS 9100, or just to improve their own processes for a more robust quality management system. So let us dive into today. Our webinar objectives: first, to develop a robust problem statement. This is really the cornerstone for your root cause analysis so that you can get good definitive results out of your root cause analysis. It's a way also to manage what we call uncontrolled branching or scope creep, when things just seem to add on and expand your root cause analysis, and soon you're now drifting away from what you originally identified as your problem. And then key to the root cause analysis process is assembling a data collection plan so that you can rule in or rule out potential causes that you've identified. And in that data collection process, we will look at some tools that are useful, whether it's a low frequency type event or even a repetitive recurrence type event. So before we jump in, we have a little bit of a poll. Just kind of want to gauge some folks and where you are at today. And you should be seeing a poll launch on your screen that'll ask what tools are you using to conduct root cause analysis, whether it's Post-it notes and whiteboards, company forms, spreadsheets, or even a QMS software. We'll give everyone just a moment or two. Let everyone weigh in. Okay. So I think the poll results are being shared. I don't see it on my screen, so maybe Raquel, you can kind of overview what percentage we're seeing from these kinds of tools.
Yeah, I sure can. So it looks like overwhelmingly company forms is number one with 73%. followed by spreadsheets at 45%, Post-its and whiteboards at 31%, and about 26% of the audience is using QMS software to manage RCAs.
Ah, very cool, which kind of feels like then the majority of our audience does have defined processes and procedures for their root cause analysis corrective action process. So you've got, some company forms that are guiding that content on how you walk through that process. So awesome. Thank you all for participating in that. So we'll start off with our first topic here, identifying the problem. This is a way to start prioritizing what are the projects or problems, if you have many, or at least a few to deal with. And I'm sure we've all felt that at some point in time. We've got several issues happening. Where do we start? So think about some of the tools you may use today in other maybe prioritizing activities or schedules. These same tools, a Pareto diagram on screen, is a way to help you identify which problem or problems is occurring most frequently. Now you'll see on the vertical axis or the y-axis says count or cost, and the x-axis or the horizontal is the failure categories. Well, those failure categories could be, failure codes or a script. What's interesting about the count or cost, and I encourage, if you can, first do it by count. How many pieces or how many times has this failure occurred? And then secondary, if you have a cost, whether it's cost of the part or cost of where that failure is at that point in time, can potentially rearrange a couple of those bars. Where we see that failure category C is first in count, and then category E. If you add the cost factor, that might actually switch category E and category C. So you may want to address the thing that costs you or has a higher financial impact more so than the one that just has a frequent count. This is just added information that can help you focus your efforts to solve a problem that may have a bigger impact to you and your organization. Another great tool to look at identifying the potential issues or problems to address sooner than later is looking at a run chart. There's a very simple one we have on screen to look at the variations in the process. Where are the spikes occurring? Is something looking to be seasonal or cyclical, thinking of the cycles that could move across a month, a quarter, or even a year, or even down to something more finite as in within a week or a day? What does that look like over time? Do we see some patterns emerging that we may want to address in a root cause analysis type process? So after we've prioritized or confirmed what is the problem or issue that we want to address, the key is identifying and assembling your problem statement. And it's all about the details. So the problem statement, I'm going to give you a really good recipe here to compare, even contrast how well you may have done in the past. The problem statement, first and foremost, this is something I'm sure we all do, should tell what is happening. What is the defect? What is the specification or requirement that is not compliant, that is in violation of, whatever it might be? Dimension 1, 2, 3 is oversized. Test 4, 5, 6 failed. What is the thing that you are looking to address? Next, where was the problem found? Where in the process? Where in geography? Think, was it at the customer location, final inspection, shipping? Was it found domestically in your country or internationally at another customer's location? The where was found is very key to identifying how far in the process that defect may have escaped or may have been recurring, to give you an idea of how big the problem might be. When was it found? Thinking about from assembly, installation, inspection, testing. Was it found at a supplier, you're receiving, or even at a customer at the end use? Gives you an idea of how long this problem may have been occurring or how long the defect went undetected. If it made it through your system and into potentially a customer, or has it made it through a supplier system and you found it as part of that customer supplier relationship? How much? How much has it occurred, as in how big of a lot rejection or batch rejection? If you have a percentage, 5% of the current batch of 100 pieces, can you give exact quantities or percentages if it's useful to show, was it an entire lot rejection as in 100%? Was it a small rejection as in only 1 or 2% has failed? Can you relate it to a shift worth of production or a week or a month that may have had the same recurring defect? Can definitely give you insight as into the extent, how much has this problem recurred, and how much is it impacting your production from the traditional, maybe 1 or 2% attrition, if it's impacting a much larger percentage of your actual production. Gives you an indication of what's happening or eating up your resources. Who? Now, this is interesting. It's not the who did it. It's not the operator that happened to be at that workstation that may have been a part of that defect. It's the who was impacted. Was it an end use customer, for example? Was it the next workstation, as it impacted a delay in your overall production process? We don't want to put the who may have committed or contributed to the error, because we don't want to play the blame game. The who is only if it's relevant, as in who was impacted by this failure, whether it's for a delay or something that may have even it caused an injury down the line. These key elements, what, where, when, how much, and who, only if it's relevant, really make up a robust problem statement. And a good problem statement becomes the baseline from which all root cause analysis success and completion can be measured. So I hope you're all thinking about that next root cause analysis or problem that you'll be addressing, and hopefully you use this little bit of a checklist or recipe to ensure you've got all the information you need to then begin your investigation. So thinking about the problem statement in and of itself, where you can add in additional data, using variable data instead of attribute data, as in exact measurements. It is 1/2 inch undersized or 0.25 millimeters oversized, versus it failed, or no go, or it was rejected. The more detail you can provide, the more you understand how out of specification or out of tolerance your defect is. Use clear operational definitions, that is, using your technical requirements. What is the requirement? What is the violation or the non-compliance? Key element in this, your problem statement should not point toward causes. You're just stating the facts. What do you know? You can certainly list some potential causes off to the side. That's not a problem. You've got good information, capture it. but not in the problem statement, because you want to look at the facts so your investigation will address the actual problem statement that you have constructed. Now you can, if it's relevant, if it's desired, include the impact, as in delayed shipments to the customer, caused an injury in use or in installation, whatever that might be, to provide a sense of severity of this failure or the defect that you're working. So where you have this kind of information, that can certainly be added to your problem statement to enhance, the level of detail, the level of robustness, if you will, when you start your root cause investigation. So let's do some compare and contrast. Here's some examples of poor problem statements. If you think about it, computer downtime is too high. Too high compared to what? Is there a goal? Is there a standard? Is there a target? Downtime is too high over what period of time? Is it the last week, month, quarter, year, or just this afternoon? What's the impact? Is it just happening in one location, or is it impacting the whole company? What's the level that we're dealing with, or the scope of the problem? Here's another one. Number of errors have increased from 70 to 400. Yikes, that sounds like a big thing, but what's the context? Over what period of time? Week, month, day, year? What type of errors? Is it data entry? Is it production? Is it shipping? What's the context? Who's impacted by this? Is it just detected internally, or is this impacted a customer? Here's another one. Amount of time to respond to inquiries has increased in the past 3 months. That almost sounds alarming, but what's the context here? We know that there's inquiries the time to respond to inquiries has increased. What kind of inquiries? What's the increased time? 30 seconds to a minute? A day to a week? What's happened over the last 3 months? What was the original response time? Is there some type of service level agreement with the customer that we're not meeting? What is it that we're trying to solve? And here's another, lastly, 3% of customers with reservations do not have a room available when they arrive at XYZ hotel. Okay, we have some more information. We've got a 3% of customers do not have a room at this hotel. We've kind of got what seems like a situational thing, but what's the context? 3% of customers over the last month? Was it over a holiday? Did they all have reservations that were made online, on the phone? Give us some other context. Did those customers try to check in early versus, at the appropriate check-in time? We're not quite sure of what is the problem we're trying to solve. So here are some better problem statements to kind of give you an idea of using our recipe. The number of purchase order data entry errors in purchasing have increased from 70 to 200 within the last 6 months compared to the previous 6 months. We've got more information. Yes, we could always add more data to this, but now we've got some good context to address data entry errors in purchasing that seem to have increased, significantly over the last 6 months. Here's another one. Amount of time to respond to IT trouble ticket inquiries has increased from 10 per week to 20 per week within the last 3 months. Yes, we could certainly add more data here. We now have a good sense of what is the issue or process that we want to investigate in our root cause analysis investigation. So hopefully this gives you an idea of how to use that root problem statement recipe to enhance your problem statement assembly, so you've got something very specific and robust to attack in your investigation. So poll question number 2. What would help your team the most to improve your root cause analysis processes? Check all that apply. Does the team need more training on different methods? Do you think you need a better defined data collection plan? Would you like better tools like a QMS software that automates and tracks all root cause analysis processes? Or do you feel like you've got a solid root cause analysis process, no additional help is needed? So we'll let everyone just take a couple of minute or two to cast your votes, complete our poll, get a little feedback just to gauge where you might be at in your root cause analysis processes.
We got a few more coming in, and then I will share the results.
Okay, great. Thanks, Raquel.
All right, the results are in. Looks like overwhelmingly about 75% that says that the team needs more training on different methods, followed up by a better defined data collection plan. And about 41% said they would love better tools like QMS software to automate and track their RCAs. And 5% say they have a solid RCA process and they're good, no help is needed.
All right, well, fantastic. And these are the kinds of things that can help you reflect as a member on, in your root cause analysis process on where you could identify what type of training you might need. And hopefully these webinars will give you some ideas of some tools and tips and techniques to help focus some of your efforts, as well as where to go get more information. So thank you all for participating in the poll. Speaking of data collection, we'll talk about developing a data collection plan and some tools you can use to collect data in our search for answers in our root cause analysis. So the type of data that we can collect in our root cause analysis investigation, variable data, that's measured data. You've got specific measurements, you've got specific information that's on some type of scale, whether it's volume, testing results, measurements, etc. Attribute data is different. That's simply counted data. How many passed, how many failed. You don't know what type of failure or how much it failed. Just it failed or it passed. You have textual data, words. Think process reports, your travelers, your test data, inspection reports. Those are words that you can review and get more information regarding the failure or problem at hand. Then we have the 5 human senses. You can observe what's happening. So you can see, watch the process, look for potential issues or near misses. What you might hear in an interview with someone who's walking through or demonstrating the process. Oftentimes we're observing and interviewing at the same time. Yes, there's other senses you could be using, from smell, touch, and if you're in the sommelier or beer tester, you can also use your taste buds as well. But each type of data has specific tools that you can use to gather that kind of data and help you analyze it in your root cause investigation. So thinking about the kinds of data that you can collect to verify or rule in or rule out a particular cause, let's talk about data search strategies. So you're looking for patterns in the data that you might be collecting, whether it's inspection data, test data, looking at travelers, etc., to try to find which causes are most likely. Where do you see the patterns? SPC run charts, for example, can help you see patterns. But we're going to look at a couple tools here. We're going to look at the flow charts as a data search strategy and a logic tree, as in how a failure could be created. There are other opportunities as well, looking at probabilities from statistics, history, science, as well as DOE, which stands for design of experiments. Those types of data search strategies are certainly available as well, but we're just going to cover the two examples of flowchart and logic tree. Essentially, what we want to do is collect data to, again, rule in or rule out a potential cause that you've identified. So in a flowchart, if you have, whether it's through your own procedure, have a flowchart of how that particular process is supposed to go, you can look at in the flowchart where the problem was detected and work your way up, up to the beginning to see where the problem could have originated. What step in your process could the problem have occurred? If you think there was a total failure in the process, you can start at the beginning of the flow chart and look for each step along the way. Can that have generated not only the problem we're addressing, but what other problems may also have occurred? It's kind of a big assessment or analysis of your process flow. If the data is available, or I should say, the data for each step in the process, what is available to rule in or rule out that process step as a cause of your failure. The information, whether it's inspection, test data, some other variable or attribute data, can tell you whether or not that failure could have occurred at that particular step in the process. Many of our flowcharts have a significant conversion point where the process itself is really broken up into many different activities. So you can actually break down that big process step into its sub-processes and look at each one of those activities to assess whether or not that problem could have originated there. So for example, if your big process flow chart shows production, well, production may be broken down into inventory kitting, assembly of tab A and slot B, machining of, the process, the box or the gear or something like that. So you can break it down into the smaller activities in that big production step. You can look at the steps in the process and ask yourself, which is the most probable, which is the most likely step that could have impacted or caused our defect. If you've got a painting problem, chances are you're going to look at the steps in the painting process, not up in inventory or kitting. It kind of helps you focus where in the process to look. If you've got a lot of steps, even in one process, break it down into smaller activities. A lower level flow chart can help you identify where that process is most likely to have occurred. A process-focused logic tree. So a logic tree can help you identify what potential causes could have led to your problem. So in this particular case, we have a calibration error is our problem. And you can ask the why or how could we have a calibration error? And you can look at what steps in the process, what elements or tools were involved that could have caused our calibration error. In the example here, we have equipment, the calibration standard, information, the technician, and the environment. So in this particular situation of our calibration error, we would ask why or how could any of these elements have caused the error? Well, we discovered that we had an issue with the standard that was used, and that caused our calibration error. We would ask why or how could that standard have caused our calibration error. It could have been the wrong standard, it was not stabilized, or the standard itself was out of calibration. And then we would ask why or how. In this case, the standard was not stabilized. That could lead to our calibration error. You'll see that I have why and how listed under each of our elements here, thinking about the concept of the 5 whys. This logic tree is essentially integrating or incorporating the 5 whys into this logic tree. So you can explore several different potential causes and ask the why. I've also added the word how, because why, the word why, can sometimes be perceived as defensive. All you parents out there, when your kids have asked you why, you get a level of frustration and then cut off the conversation. When you turn it around and ask how, now someone is demonstrating or exploring the process in detail and doesn't feel that they've made a personal decision. So think about the 5 whys could be turned into the 5 hows. And this logic tree gives you the opportunity to do a 5 why. It also expands your field of view, if you will, to different elements in the process. It could be different functions involved in the process or different activities involved in the process, as a way to start honing in on the potential cause, the most likely cause of the problem that you identified in your problem statement. So we think about data in and of itself, and this gives you some ideas of what types of data you could collect and where you might get that data. So if you think about our problem statement, our outcome, our defect on the why, the outcome measure, that why resulted from several input variables, those process variables, the X's on the left. So you can look at the outcome measure as well as looking at the inputs, as in product, process, material. If anyone's heard the 7 M's of variation, could be material, method, machine, etc. What are the elements that could have variation that can cause our outcome as in a defect or rejected part? The logic tree can certainly capture those elements of variation and help you understand which one of those could have caused the defect or problem that you're dealing with today. So attribute data I mentioned before is really just a count of good or bad. So for example, we have 5 different batches, and our attribute data shows us that 4 of those batches were okay, and the 5th batch was no good. That doesn't give us a lot of information about what was happening in those batches 1 through 4. If we look to collect some variable data, as in the actual measurement values, we can see different trends emerging and what's happening with batches 1 through 4 that could lead to our batch 5 being no good. So on the top line, we see that the process is kind of stable, but it's drifting on the high end of the specification. The middle example shows that there is a lot of variation, the ups and downs, and then the bouncing out of specification. One could say that middle example shows an unstable process. And the last example shows a very slow drifting out of specification, thinking of a tool that is wearing out and is no longer effective in holding a specific tolerance, that could lead to that drifting out of specification. Collecting variable data helps you see the pattern in the process, the variation that can lead to an out of spec or a defective part or process. So let's talk data collection versus problem frequency. There are some good tools for data collection if you have a low frequency type failure. Things that aren't happening every shift, every batch, every week, every month. It might happen occasionally, once or twice a quarter, maybe once a month. So we're going to explore some tools here in observation and something called component swap. But the other tools there, interviews, looking at process records, even a failure analysis, can be quite useful in those low frequency events, along with any other event, but more geared towards low frequency. For those things in more of a repetitive situation, maybe happening kind of regularly over a shift or a week or a month, you can use a check sheet to kind of tally or count the issues, but we're going to explore a concentration diagram and a multi-factor data collection, think pivot table for all you Excel fans. The problem data patterns. What we see in our data collection can help us hone in on the most likely causes. Rule in the most likely, rule out the irrelevant or less likely. Observation. Thinking about how you can observe the process, see it happening, look for near misses. Be aware that as people know you are observing them, they may act differently. So is there a way that you can be an unobtrusive observer, as in people don't know that you're there or forget that you're there? Taking different observer viewpoints in front of, behind, overhead. So many companies have cameras in their facilities for just this purpose, to watch the process, not to monitor people, but to watch the process and look for near misses. What can you see side to side, even above, that can be enlightening as to potential causes? Then there's something called component swap for those low frequency events. If you're not sure if the failure is due to a component or subassembly or the overall assembly itself, well, you can simply take the subassembly from line A in step 1 and try to install it in the line B in step 2 and see if the failure follows the subassembly or if the failure stays with the initial assembly. So think about where you can put that suspect component or subassembly into a different assembly or kit and see if the problem follows the component or stays in the original kit. That can definitely help you confirm where the problem may be occurring. The concentration diagram. This is a fantastic tool, especially for recurring problems or recurring defects. This particular picture is of a steel wheel, and the tube, you know, where the tire inner tube comes out is right there. And you can see on this steel wheel example where we've actually marked the confirmed defects over the course of a couple of batches. Well, you can see where things are happening more frequently in this particular region around 11 o'clock on the steel wheel, and less likely, less repetition in these other areas. So now we can focus our attention and our investigation regarding this particular area on this steel wheel. You can use a concentration diagram using a product, even a facility. Where in the facility is a particular problem occurring? Is it happening in inventory, in kitting, in workstation number 5, or in shipping? Is it a facility or equipment related issue? For those in more of an administrative function, what are the continued problems we're having on our form? Are people forgetting to fill in box 32? We're getting the wrong information in box 5. That can help you focus your efforts on where the problem is occurring versus trying to address the whole process in and of itself. Focus in on the area that has the problem can be more productive in identifying those root causes than trying to address the entire process. A multi-factor data collection, think pivot table. If you have a lot of data, you can turn that big spreadsheet into a pivot table, which summarizes data. In this particular example on the left, we've got the insurance companies that are coding different types of claims: geriatric, heart, oncology, orthopedics, and pediatrician. And you can see that there's different insurance companies that are processing different numbers of claims based on these categories. From that pivot table, you can construct a bar chart that can show you the patterns that may be emerging from whether it's a particular production line, part number, workstation, shift. This allows you to slice and dice the data and hone in on where the problem is happening, how often, how much, what's the percentage, so that you can go look at those areas, those elements in the process, and focus your investigation. The types of data that you want to collect can be assembled into a data collection plan, especially if you have more than one person that may be supporting this data collection. Your data collection plan can be, it does not need to be complicated, very simple as who will collect what data, when, and why. Why, as in the what cause do we think this data may support to rule in or rule out? What variables, sample sizes, time frame? What precision or resolution do we want to see in our data? And how will we collect it? Excel spreadsheets, photos, reports. What is it that we're looking to get so that each person collecting data knows what they will collect and has a complete assignment in their data collection? And I love this last line: calibrate both people and equipment. If you will be using your own equipment to collect data, ensure it is appropriately calibrated. Calibrating the people ensures that they know what data from what source, what the sample size is, as in I want 50 samples over the last 6 months, and if we have data to the 4th decimal point, I would like to get that amount of precision. And I would like it all to be posted on an Excel spreadsheet. And essentially, it could be as simple as this data collection plan. What's the possible cause we're investigating? What data will I collect related to that cause? The sample size, do I want 10, 50, or 100? Over the last week, month, quarter, or year? Will the sample type be from inspection, from test, from production? What's the precision? Do I want attribute data pass fail? Do I want the actual inspection results down to the 4th or 5th decimal place? Who will coordinate that data? Will it be Susie, Bob, or Tom? And how will we analyze it? Do we need to do an SPC run chart? Can we use a pivot table? What is it that we'll do with this data to rule in or rule out the possible cause we have in our far left column? So opportunities there to focus your data to the possible causes related to the problem statement that you assembled, very specifically with lots of good detail. So kind of wrapping up a little bit so we can open it up for Q&A. There are some great tools and some more training courses and webinars, if you will, that you can learn more about the root cause analysis process. ASQ, the American Society for Quality, does have an online course or remote learning. It can also be done on site. If anyone wants to bring this course to your organization, there are public courses in August, October, and December with the link there. Also, there is part 1 of this series is available on the Intellect website that you can download to get the first session. And then Raquel, I'm going to hand it over to you to talk about what's coming up at Intellect.
Yeah, thank you, Dani. Appreciate that. Yes, so for those of you who are interested to see what QMS software can do to help to automate RCAs, CAPAs, and nonconformances, we're going to have a live demo next Wednesday, July 19th at 1 o'clock Central, kind of giving you an inside view into those applications. That way you can see if that is something that can help you as you are developing your RCA process. And before we get into the Q&A, just a few items. So if you want to connect with Dani, we've got her email and website posted there. You'll get the slide deck to this a little bit later today, so no fear. But you can also put your cell phone camera up to the QR code next to Dani's picture to connect with her on LinkedIn. You can find more information about Intellect at intellect.com. Once again, that live demo is happening next Wednesday. You can register for that as well on our webinars and events page. And just to, we just announced internally and now, I guess externally, we are going to have our next webinar on FMEA on Wednesday, August 16th with ASQ instructor Dennis DeVos. So some more information for everyone here. You can feel free to share with your colleagues. These events, as always, are free. Heading into the Q&A, please, if you've only got a few questions, but if you have your questions, please put it into the Q&A box and we will get started. The first question we have here is, Dani, what are some of the common missteps that you see in developing RCA processes?
Oh, great question. Honestly, I'll say that the missteps start at the problem statement, as in there is not enough data to really define what is the problem that is being investigated. And in the problem statement, I have seen all too often where possible causes are integrated into the problem statement. So it's kind of suppositions. So the investigation may not be as objective as it could be with a problem statement that has the facts, giving the details of what not only the defect is, but its impact in the process, from total lot rejection to simple ones or twos. So it really, the most pervasive problems I've seen is really at the start. Getting that problem statement right makes the root cause analysis process so much easier, so much more focused, and usually leads to some really good and impacting corrective actions to really prevent recurrence.
All right, thank you. Our next question, what are the biggest challenges you see with using Excel and forms for RCAs?
So great question. So sometimes the form may be limiting, as in doesn't let you kind of add more information or add more data. So that's where I encourage, if your form gives you kind of very specific steps, you can certainly be adding some data, adding information on an attachment or an appendix to keep things focused there. so that you can show your work as you were investigating potential cause or causes. Sometimes the form has a simple 5 why, a linear 5 why. I encourage looking at the logic tree as a good process focused 5 why that can open your field of view. Excel, great tool. I use it all the time. I'm kind of an Excel nerd. What I like about Excel is that you can capture a lot of data, a lot of information, and then use a pivot table to sort and sift through the data for trends over time, over shifts, over batches. The caution might be, does the data in your Excel spreadsheet really pertain or connect with the problem you are investigating? Whether it's a particular measurement or test value, whether it's looking at the operations from travelers or inspections that relate to the problem you are investigating. So it's always a good idea for the data that you have to confirm that it does relate to or associate with the problem you're investigating, whether it's a part number, a process name, or a test setup or something like that. Is it related to the thing you're investigating? I hope that helps.
Okay, thank you. Next question, how do you prevent people from immediately leaping to solution instead of exploring root causes? Also, some team members are more vocal than others.
Great questions. So it does take someone with some good root cause analysis knowledge when starting in that problem definition step to recognize when someone's trying to put potential solutions or causes into your problem statement and say things like, that's a great input. That sounds like a solution or a cause. Let's put this over here. We don't want to lose it. But what are the facts that we know about the problem? So you're still validating someone's input, but you're not letting it creep into the problem statement that could then send you off on a different path versus really what the problem is from all the data you've collected. And then when it comes to some are more vocal than others, this is where you could, depending on the team, try to have a facilitator, someone that's good at checking in with everyone on the team. If you're leading the root cause analysis team and you feel comfortable checking in with each person. Hi, Tom, what do you think? You know, Tom, based on that, we've captured your ideas. Great. Next, Susie, how about you? And you just keep going around the room and people will get the idea that there's a pattern. Everyone gets to take their turn, so no one gets left out. There's other great facilitation tools and techniques out there that you can explore, whether through ASQ or other online searches. But facilitation is definitely a key skill set when you have a root cause analysis team to ensure you hear from everyone.
All right, thank you. Next question, how does vendor-caused issues factor in when they don't respond to requests for information? Do you put the data on hold or make adjustments?
Ooh, that is a tough one, and unfortunately probably more common than we'd like. When data is key from a supplier, I would almost suggest that trying to approach them at several different levels to try to get that data so it's not impacting you and your investigation. All too often, we try to approach suppliers quality to quality. Consider that we may need to engage your purchasing to connect with their sales. And if you need to engage others, more of a senior management kind of thing, not to be aggressive or in a negative way, but to do the kind of pleading sense, we need your help to investigate this issue or problem. If that still doesn't work, is there other historical data that you can use from previous deliveries or even previous corrective actions with that supplier to at least keep some of the activity moving while you're trying to collect new data. Another option is, as product is being received, if you're still receiving product from a supplier, then you may need to collect a certain amount of data in your own facility, in your own receiving processes, while you're trying to explore getting more data from that supplier. So one route is escalation, 2 is historical data, 3 is collecting new data as parts come in, as a way to at least bridge some of the gap while you're trying to get data from the supplier themselves.
All right, great. Next question. What is the best way to prevent scope creep?
Honestly, I'll say starts with a very robust problem statement. The more focused your problem statement is, from defect, the where, when, who was impacted, how much, that is one great way to prevent scope creep, because that other, well, what about this? That's not our problem. That's a good thing for the next project. Thank you, Sally. Let's focus on the problem we have here today. And keeping that problem statement, or even reviewing it at every root cause analysis team meeting, will help level set folks and keep them on track. You can even appoint someone to ask the question, almost be the devil's advocate. Does that relate to our problem statement? Yes or no? If not, it goes on the parking lot. If yes, it stays here. There are other opportunities of folks, hey, while we're here, can we solve these other issues that we're having with the same process? Same question, does that relate to the problem we're trying to solve? If it's a process improvement, that's a great idea. Thanks, Bob. Let's put that in the parking lot. We may be able to address it when we get to corrective action, but let's focus on the problem and the causes to that problem in this particular case. So it's kind of being a little focused, and I'll say a little assertive on keeping people on track and acknowledging all those other great ideas, putting them in a parking lot. Even saying at the start, for other things that are good ideas or might be related, we'll have a parking lot and see if we can address them while we're moving through the process. But that's not the focus we have right now. I hope that helps.
All right, we've got one more question. Who should facilitate the RCA for CAR? What are the key factors to ensure RCA is done correctly?
Oh, great question. Facilitating, this is where you could probably use, thinking those that are in the quality function, we're a good facilitator because we work with so many other functions, engineering, purchasing, production, etc. So we can work to engage all those relative or associated functions and make sure our team members are heard, from engineering, production, inspection, test, etc. Thinking about who would verify or validate, that really, I think, would come in the corrective action phase, because there's going to be certain process owners. Where did the problem occur, in which process, that they can verify or validate whether or not that problem has recurred. You could assign it to an independent function, like someone from quality, to verify the effectiveness. Sometimes those are done as part of the corrective action process, that after 90 days or something like that, we'll look at the data and confirm we haven't seen recurrence. So I think it's based on your organization, based on the process or the issue. Sometimes you even may need to have customer input. If problems were found at a customer's site or usage, you may need to check in with them to see if they've had any problems, to verify the effectiveness of your corrective action. So it's kind of multifaceted depending on the problem, the organization, and where it even occurred. May give you an insight of who can help verify the effectiveness.
All right, thank you, Dani. And finally, we do have a question about the link to the live demo webinar next week. It is on that webinar and events page on our Intellect website. You have to scroll down a little bit. We'll work on moving that up to the top of the page, but there will be a link to that in the email that we send out later on this afternoon. So it looks like we are done with the Q&A portion. Thank you so much, Dani, for all of this great information. We really appreciate your insight and knowledge. And thank you everyone for attending today.
Thank you so much.